In the section M.1.10, we're going to solve real-world situations using expressions, equations, and inequalities. And so expressions are mathematical phrases that contain numbers, variables, and/or operations. Equations relate expressions that are equal to each other, and inequalities relate expressions that are not equal using comparison symbols such as greater than or less than. We've done some of the equations and expressions back in one of the first sections when we were doing the algebra solving equations. So our objectives in this particular example are to find, identify the variables based on real-world situations, identify the keywords which describe specific mathematical operations such as add, subtract, multiply, or divide. It's easy to draw a sketch of the situation if appropriate to help clarify or identify variables. You got to determine the necessary operations, some contextual clues. We got to formulate an expression, equation, or inequality using the identified variables and necessary operations. We're going to solve the equation or the inequality and add the correct units of measure. Then we've got to assess the reasonableness of the solution or answer to the problem. In other words, does the answer make sense? Here are some examples of expressions, equations, and inequalities, so hopefully you should be familiar with all these particular different things. To be successful at the TEAS task, you'll need to practice shifting between the concrete and the abstract. In other words, using actual mathematical equations like examples up here versus using words, written words that you have to translate back to these expressions, equations, or inequalities. What is very important is that when you're doing these word problems, phrases become expressions and sentences become equations or inequalities. So you have to be very careful about when you're using the inequality symbols. Back in one of the prior sections of the TEAS textbook, we gave you this same handout of keywords and phrases for problem solving. These were the examples that were on there. Now we've added the inequality symbols. You've got your less than, you've got your greater than, you got your less than or equal to, and your greater than or equal to. And it's very important that you make sure you use the correct symbol in your particular problems when you are setting them up. So make sure you're familiar with all these little keywords, both for addition, subtraction, multiplication, division, the equal sign or equality, and now the inequality, which has been added for this particular section. Back in the prior section, we already talked about general strategy for problem solving. You basically have to understand the problem, and these are some of the examples that I tell students to always do, is read the problem at least twice, decide what they're asking for in the problem, choose a variable and write down what it represents. It doesn't matter which variable you use, just kind of be constant. Write any other needed expressions using the same variable. Then you want to translate the problem to an equation. So write the equation to solve the problem. This is your algebra part. Then you're going to solve the equation, which again is the algebra part. Solve for the unknown quantity in the equation, just like you would any regular algebra problem. Then interpret your answer. Check your answer. Does it seem reasonable? So if you kind of follow these rules, I know the TEAS textbooks use a little bit different wording for this, but the steps are basically the same thing. So we're going to use these steps on the problems that are in your book. This is the problem that's in your textbook. It says, suppose Xavier attends a local fair. He spends a total of $25, which includes $5 admission to the fair and 8 rides. When he returned home, his dad wants to know how much it costs for a single ride. So this is a word problem. Identify the extraneous or erroneous information. In other words, stuff that you really don't need to know to work this problem. And then pick a variable and tell what it represents. That's where it goes to the understanding. We're going to just let R equal the cost of one ride because that's what his dad wants to know. And then we've got to decide what the context of the story tells you about the relationship. We know he spent $25. We know to get into the fair it costs $5. And we know that he had 8 rides. So if we do 8 times the cost of one ride plus the $5 admission fee, that's got to equal the $25 that he spent. Then we just basically solve our equation just like we normally would. We're going to subtract 5 from both sides. Then we're going to divide by the number beside the R, which is 8. So 20 divided by 8 is going to give us 2.5. So each ride costs $2.50. Make sure you put your money in with 2 decimal places. Now this answer is reasonable because it's a small fraction. The way that we could check it is, does 8 times 2.50, or $2.50, plus the $5 admission equal this $25? And it does, so we know we have the right example. In this next example, we're going to follow basically the same rules. We're going to understand the problem, we're going to translate it to an equation, then we're going to solve it, and then we're going to interpret our results. So let's read the problem together. It says Vivian is at the supermarket and wants to spend no more than $70 on groceries. So she can't spend more than $70. She can't spend $70 and even 1 cent extra. She knows that she will spend $45 on necessities, but wants to buy pepperoni, which costs $5 per pound. And she wants to know how much pepperoni she can buy while staying within her spending budget. So she just let P equal to pounds for the pepperoni, in other words, how much pepperoni she can buy. So she defined her variable or understood the problem. She knows the total cost of the pepperoni is 5 times P, or $5 per pound. She knows she's going to spend $45 on necessities, so that's the plus 45. And finally, the total is no more or less than or equal to $70. So she has to use the less than or equal to symbol. She could use the less than if she wanted to spend less than, but she wants to spend up to a max of 70, so we're going to have the equal sign also. Then we subtract 45 from both sides, then divide by 5, so P is going to be 5 pounds. So she can buy no more than 5 pounds. So in this example, we had an inequality. The key word is no more than or less than or equal to $70, so we could use this particular symbol. So be very careful when you're doing the inequalities, whether or not you need to have the equal sign up under the symbol or not. Here's another word problem that I've got set up. We're going to decide whether it's an equation or an inequality once we start reading the whole problem. It says on the last 3 math exams, the student scored 90, 89, and 82. What score must the student earn on the next exam to have an average above 90? So above 90 means it's got to be greater than 90. It can't be 90 because we want above. So my solution was, I'm just going to let X be the score that it takes on the next exam. So we've already taken 3. So once I take the X exam, I'm going to have, that's the 4th exam. So to find the student's final average, I have to add the 3 tests the student has already taken, plus the score for the 4th test, then divide by 4. So when I do that, I get 261 plus X divided by 4. And since the final average must be above 90, this must mean the average must be greater than 90, so our inequality will be true. So I take 261 plus X, add those together, then divide by 4, and then want that to be greater than 90. So what we do is we multiply both sides by 4 to clear out the fraction. To get this, then we're going to subtract 261 from both sides to get X by itself. So this gives us X must be greater than 99. So the student has to make a score of 99 or greater to have a final average above 90 in this particular example. So this is kind of showing you how inequalities work with the equal sign and without the equal sign. Once you read all the pages in your TEAS study manual, then you should be ready for section M.1.10. Then you should be ready to do your practice problems. Most of these are going to be either equations or inequalities. The examples here looks like they're all going to be inequalities, so be very careful when you're actually solving the problem to make sure you get it correct. Some of these will make you solve the whole problem. Some of these are just asking you about a particular step once you get it set up. So good luck on this section.